You're listening to the Things Podcast, brought to you by the Things Industries.
Roelof Koopmans, thank you very much for making time available here. How's it going here? Oh, Amsterdam. Home match, I would say.
Yeah, for me, it's great to be here. I live in Switzerland since 30 years.
Yeah, that's the reason.
Amsterdam's always great, but particularly the show here. You see so many faces and people that have been meeting over all these years here. For me, it's the sixth show I'm joining, and it's get bigger and bigger. And you see the success all these companies are making. Very rewarding.
Yeah, and it's also it's now I see operating systems. I see 3GPP, so it's getting broader. It's a broader audience, right?
Yeah, I mean this year, it's not just limited to LoRaWAN wireless protocol, but it's also opening up for other wireless protocols, which makes perfectly sense because customers and vendors that manufacture hardware, they work with all radio protocols, not just LoRaWAN. So they opened up for a larger audience, and it was, as far as I understood, there are almost 2,000 people joining here. So you can say big success.
That's a big success. So it's growing. That's good. And it also means that IoT is not really hype. Everybody's saying, well, IoT is a hype, but it's not. It's really there. It's getting into our lives daily, in our offices, and the device everywhere needs to be powered, and batteries are a problem, and that's where you pop up.
Yeah, right. We believe in a battery-free world, not just from a sustainability perspective, but also because IoT solutions, if they're going to be used at scale, I talk about hundreds of thousands of sensors deployed over multiple sites, it's just not viable to start replacing batteries after a couple of years or even after a couple of months. That's a maintenance cost that's so huge that companies don't even get started to deploy a large LoRaWAN solution or IoT solution because the battery is just getting in the way in terms of business case.
Yeah. Coincidentally, I'm also as a consultant working, and I'm working on a project where we have headaches of batteries, devices which need to be, batteries need to be swapped. So that's really a topic. So when you can avoid swapping batteries, I know from my own point of view, it can save time and cost.
Yeah, if you have like 100 sensors in a building, somebody could change batteries, right? It costs me maybe a day. Yeah. But as I said, if you have 10,000, 100,000, millions of sensors like trackers on pallets and actuation, so how are you going to face?
Yeah, it's just a nightmare. It's a logistical nightmare. Okay, so there we come to your solution, and I think you're harvesting from light, right?
Yes, right. We are Dracula Technologies. As the name may suggest, we work very well in the dark.
You live in the dark,
right? So our light-based energy harvesting, which is called organic photovoltaic cells, can harvest from very, very little light enough energy to power up an IoT sensor.
Okay. So your PV solution, it's developed for indoor use, right?
Absolutely.
Okay. And can you give me an example? So what does it mean, for example, when you have a typical housing of a let's say a 10 by 10 centimeter device, what kind of energy comes from that? Can you explain what kind of power?
With this kind of light conditions, because it all depends on light, all right?
Or do I have to think, or do you have to think about thin paper sizes?
No. I mean, 10 by 10 is quite a big mode, right? Oh, usually we do smaller sensors for companies, but 10 by 10, think about maybe 1 to 2 milliwatts.
Okay, the power's not too bad.
That's right. So you can power up a sensor that maybe transmits every 10 minutes or 30 minutes. If you want to have real-time transmission, of course, that's not going to roll nowadays. But if you have a supercapacitor or a rechargeable battery, you harvest the energy, you store it in your storage elements, and you need it when you're basically going to transmit to your cloud application.
Okay, so your use case is basically you have a device which is in a deep sleep mode. It harvests energy, it stores it in a supercap, for example. It wakes up and then it transmits, for example, how many temperature or CO2, whatever.
Right. Or you have actuators or sensors that actually do like movement based. As soon as you move a tracker, it will just transmit, okay, I'm moving, this is my location. Okay. You turn silence, it will transmit again, okay, I'm at my location, I arrived. So you can have very smart middleware actually that basically does, firmware that does that smart configuration of those modules.
Okay. And what does this mean when you have got when I've got a solution, for example, which I need to redesign? So I'm successful in the market of, let's say, temperature sensors, and I would like to, we're going to the next phase, and I think, okay, now we would like to do ambient harvesting by design. I presume it's not an add-on; it's a by design thing. What does that mean? Do I need to reselect microprocessors and the whole BOM, or can I simply add on your existing solution and instead of a CR 2302 battery?
There is a bit more to it. With energy harvesting, your electronics design would have to be sort of reviewed against optimization of the use of power.
Of course, yeah.
Right? So are you using the right CPUs, for example?
Yeah.
Low power, ultra low power. In terms of loading and charging, you can optimize it. So it's not completely trivial to do a redesign or a green field design of an energy harvesting device.
Yeah, and that happens anyway. Yeah? So once in a while, components get end of life, and you do need to redesign. In the end, always that always happens with successful products. Well,
I mean, we have electrical engineers that support our customers
okay.
with selection of the PMIC, which typically power management IC, that has to work very closely with the storage elements and the energy harvester. And this is the way we try to help our customers to get up to speed in optimizing their electronics for low power consumption flows.
Okay, Roelof. Now this was the leaflet part. Now the serious part. What do I need to allocate as a BOM build material cost for such a solution like 10 by 10 series? What do you have to think about?
You mean additional cost?
Yeah, just cost. I'm interested in such a solution, but I have to...
Maybe between $1 or $2.
Oh, that's not too bad.
No.
That's not too bad.
I mean, it's more expensive than batteries, unless you have lithium batteries, which are also expensive. Yeah. But it's not a showstopper from a cost perspective. And I'm not talking here about like millions of pieces. We're talking about thousands of pieces.
So when I've got a few thousands of devices, I just InDesign a SuperCare, have your PV up and running then.
Yeah. Okay. Yeah, we manufacture based on inkjet printing.
Okay.
Which is completely customizable in terms of shape. And it's very fast turnaround. Like from a design, digital design goes immediately into automated production. So very short turnarounds for several iterations of clients. So it's not like you have to build a whole line of production with masks to print those foils. It's very flexible and very fast.
If people are interested and want to start, what is their next step?
Reach out to us, right? So website www.dracula-technologies.com, or just reach out to me. My name is Roelof Koopmans. Email address r.koopmans@draculatechnologies.com.
So I think it will be in the show notes. Thank you very much for my time. Grab a sandwich because you're very busy, and good luck.
Thank you very much.
Thanks. All best.
Thank you for having me here. Bye, Robert.